And it is time. What is up, everyone? Welcome back to the HackSmarter Twitch channel. My name is Tyler. Whether you're watching this live as it happens or after the fact on my YouTube channel, I say this every time, but it's because I mean it. It is an honor to have you take the time this evening to hang out with me and to learn some, for this evening, some web app hacking stuff together. A little bit of context. About 6 months ago, if YouTube is telling me correctly on the video, I released the first half of the OWASP Top 10 2021 room on TryHackMe. It's a really good room and it has a good mix of theory and hands-on labs, and we went through the first half, specifically 44% if I'm believing the TryHackMe room, and I've received quite a few requests on YouTube of people like, yo, Tyler, where's part 2? Because it says part 1. I never released a part 2. I don't actually remember why. I think I got distracted by maybe the red team pathway. Maybe that came out after that. But anyways, I never went back to it. So I thought, look, guys, I will come back. I will finish this room. And web apps really are one of the most important things you can learn if you want to be a pen tester. So if you're looking like, hey, I want to get into pen testing, learn web apps, whether it's through TryHackMe, PortSwigger, whatever platform that you want to use, just learn them. Generally speaking, if you become a pen tester, you will start as an associate or a junior pen tester, and much of the time you will spend your time doing web apps. The reason for that is overall at most pen testing firms, web apps are the biggest assessment that we get because web apps are so common and they're kind of like a low-hanging bug. When a company wants to try out a pen testing firm, they throw some web apps to see like, how do these pen testers do? Do we want to work with them? And then from there you can shift into internals or cloud stuff or externals, whatever you want to look at. But truly, if you want to be a pen tester, you cannot overlook web apps. So with that being said, we are going to dive right in. Let me get Twitch pulled up so I can see the chat. What up, Bottleneck? What up, Kurz? What up, Rye? Good to have all of you here. Let me share my screen, guys. We are going to be working with Cato. If you've never heard of Cato before, it is a web app pen testing framework similar to Burp Suite and OWASP Zap, but unlike OWASP Zap, it doesn't look like it was made in 90s MySpace, and unlike Burp Suite, it's not overly expensive. You can get a pro license, but even without a pro license, you get a lot of the features for free, but a pro license does give you access to like ChatGPT Assistant, so you can say, hello, robot, and this is ChatGPT built right into Cato, so we can ask questions as we go. Helps us with our web application security needs. And hot off the press, I just noticed this on the Cato Discord today. Cato Pro is free for those of you with a .edu email. So if you are a student in college and you have a .edu email, you get a pro license of Cato completely free. If you are not a student, it costs less than $10 a month. So it costs a total of $100 a year. You do the math, that's less than $10 a month. And if you sign up for a pro license and use HackSmarter on checkout, you get $10 off, I get $10 off. It's a win-win. So if you do sign up for a pro license, use HackSmarter, I would appreciate it. But hey, if you're a student, if you have a .edu email, Cato is free for you. If you go to the website, there's some information there on how you can sign up. But I'm going to do this entire room, or at least attempt it, using Cato because I believe it's a lot more accessible. At my job, I use Burp Suite Pro, and I used to do my streams on Burp Suite Pro, but I recognize many of you do not have access to Burp Suite Pro, and I would not encourage you to spend $400 a year just to get access. I use it because my job pays for it, but yo, Cato is a really cool alternative written from the ground up in Rust. So there is my little Cato commercial. All that being said, let's go ahead and dive into things. If I show you guys what we've accomplished so far. So once again, this is about 6 months ago. It's been a while since I've been in this room, but we have about 44% done. And you can see in my previous stream, you can actually catch the video on my YouTube channel. If you just search for OWASP Top 10 Tyler Ramsbey or whatever, you should be able to find it. Part 1, this is part 2. But in that part 1, we covered broken access control, cryptographic failures, injection attacks. And now we're going to dive into insecure design, and I am going to read this in its entirety, but what I like about this is all of these will explain the theory, and then we will do a hands-on lab. And now, last but not least, let me check. Yes, this is a free room, so I'm going to grab this link right here for those of you watching on Twitch. You can actually come join me. We can do this room alongside of one another. Even if you don't have a TryHackMe subscription, you can come join. Say a special hello to Reckless Gizmo and Overgrown Carrot. I'm doing well, my friend. Thank you for asking. All right, I am on the VPN. I got Cato pulled up. Let's just dive into it. I'm going to zoom in. Oh, maybe So you guys can see, not that much. There we go. Let me know if you guys can see the text okay. Insecure design. Insecure design refers to vulnerabilities which are inherent to the application's architecture. They are not vulnerabilities regarding bad implementations or configurations, but the idea behind the whole application or part of it is flawed from the start. Most of the time, these vulnerabilities occur when an improper threat modeling is made during the planning phases of the application and propagate all the way up to your final app. TryHackMe is coming out with some rooms, or maybe I think right now it's threat hunting, but if you go through their new cybersecurity engineer pathway, I think I have that right, they have a room or two on threat modeling. Would recommend it. Good stuff there. Some other times, insecure design vulnerabilities may also be introduced by developers while adding some shortcuts around the code to make their testing easier. A developer could, for example, disable the one-time passcode validation in the development phase to quickly test the rest of the app without manually inputting a code at each login, but forget to re-enable it when sending the application to production. And actually, a real-world example of this, kind of similar to this, on a web app. I can't give away too much information, of course, because I don't want to give information about clients, but a web app that I was pen testing, they accidentally deployed the development version of it instead of the production version of it, and very similar thing here. There's a lot of things that were insecure because they accidentally deployed the wrong version of it. So this really does happen in the real world. Insecure password resets. A good example of such vulnerabilities occurred on Instagram a while ago, and you can check that out if you would like. Instagram allowed users to reset their forgotten passwords by sending them a 6-digit code to their mobile number via SMS or text message for validation. If an attacker wanted to access a victim's account, he could try to brute force his 6-digit code. As expected, this was not directly possible as Instagram had rate limiting implemented so that after 250 attempts, the user would be blocked from trying further. And you can see this. You go 250 attempts, you are blocked. You're not able to brute force it. But it was found that the rate limiting only applied to code attempts made from the same IP. If an attacker had several different IP addresses from where to send a request, he can now try 250 codes per IP. For a 6-digit code, you have 1 million possible codes, so an attacker would need that, or 4,000 IPs to cover all possible codes. This may sound like an insane amount of IPs to have, but cloud services make it easy to get them at a relatively small cost, making this attack feasible. And look, I am wearing the shirt right now of the greatest pen testing firm. I don't know if you guys can see it, Rhino Security Labs. And at Rhino, we actually developed a tool for this. I think it's called IP Rotate. It's an official Burp Suite extension. Let me see if I can find it. Yeah. So this is actually a tool created by Rhino Security Labs. Dave Yezlin, I think is how you say it. He is one of our senior pen testers. I actually have the honor of, I meet with Dave every single week for one-on-ones. Really nice, really smart guy. But he wrote this. It allows you to easily spin up API gateways across multiple regions. All the Burp Suite traffic for the targeted host is then routed through the API gateway endpoints, which causes the IP to be different on each request. So basically, you could perform this attack on Instagram before it was patched with this IP Rotate tool because it's pulling all these different IPs from AWS, and each one has a different IP. So your rate limiting based on IP is not going to be able to block this type of attack. Fun fact right there. Notice how the vulnerability is related to the idea that no user would be capable of using thousands of IP addresses to make concurrent requests to try and brute force a numeric code. The problem is in the design rather than the implementation of the application in itself. Since insecure design vulnerabilities are introduced at such an early stage in the development process, resolving them often requires rebuilding the vulnerable part of the application from the ground up, and is usually harder to do than any other simple code-related vulnerability. The best approach to avoid such vulnerabilities is to perform threat modeling at the early stages of the development lifecycle. To get more information on how to implement secure development lifecycles, be sure to check out this room. This may be the room I was talking about. Let me check. Oh, apparently I didn't even finish this room. There must be another threat modeling room. I must have been working on this in the middle of something. There's another threat modeling room, I believe, that goes through this in a little more depth on the cybersecurity engineer pathway. So go find it if you're interested. Okay, navigate to there and get into Joseph's account. The application has a design flaw in its password reset mechanism. Can you figure out the weakness in the proposed design and how to abuse it? So try to reset his password. All right, we'll mark that off. Let's go ahead and grab our IP here, and let's see what's going on. So here we go. If we type in Joseph and we'll just type password, let's see what happens. All right, user or password incorrect. This is something I will check on an assessment. Looking for username enumeration. So sometimes when you use a valid username with an invalid password, it will say your password's incorrect, which tells you, hey, I have a valid username. That's actually something you would report on a pen test if you're able to script it out without rate limiting. Generally, if you can perform it 50 times with something like Burp Suite Intruder or in Rust Automate, you would report that as a low finding of username enumeration. Yeah, OWASP 2021. What up, Nate? I'll drop a link to it again because I don't think you can see past chat. And it's free, Nate, so even without your TryHackMe subscription, you can actually come do this. I already did the first half like 6 months ago. We're just doing the second half right here. But okay, let's see if we can figure out the forgot password functionality and what might be insecure about it. Let's go ahead and just intercept each one of these requests so we can see what it's doing. So we know the username is Joseph based on what the task told us. I'm curious if we use a different username. So if I use like Tyler, does it give us an error message? Let's check. So we're passing the user. I'm just going to forward the request. We can turn that off. The user doesn't exist. So there we go. That is something that we would report and something that I check on actual assessments using the password reset functionality. This is super common in the real world of being able to figure out a valid user based on error messages displayed on the password reset process. If there's no rate limiting in place, this can of course be scripted out and you get mass account enumeration to be used in brute force, password spraying, or phishing attacks. Now we do know it's Joseph. I just wanted to see if we could get some minor user enumeration there, and we can. So let's go and do Joseph. Let's turn intercept back on. We'll hit continue, and so we're passing it this cookie, which is interesting. It must just be an anonymous session, and we're giving it our user Joseph. Let's forward that request. And it looks like there's a second part of this, and that's what we're getting now. We'll hit never on that. So now we're at the password reset. So this is reset password 2.php. And so security questions, please answer one of yours. Our first is, what is your mother's, sister's, son's, nephew's, neighbor's friend name? Okay. We have, what's your favorite color? And what is your pet's current address? So if we think through this, of an insecure password reset, and if we think back to this room right here about, hey, remember on Instagram, you could brute force the 6-digit PIN. Well, this might likely be similar. So we probably can't guess the mother's, sister's, son's, nephew's, neighbor's friend name, even with OSINT. I don't know if you could get that. And your first pet's current address might be the grave or something like that. But color, spelled in the UK format, there's a limited number of colors, so it could be possible that we can brute force the colors. So that's what I'm going to try. And so we'll put like orange, but we're going to capture this. We'll hit continue here, and we're going to go ahead and send this to automate. There we go. So we'll go over to automate here, and we're going to mark orange. And so this is kind of like in Burp Suite when you mark, hey, this is what I want to modify. So we'll go ahead and mark orange, and we can do, I think if I do simple list, can I type stuff? Whoops. Oh, this is like from that. Okay, let's go back to automate. Did I break it? Let me just send that. I don't know what I just did. There we go. Okay, let me go ahead and capture this again. And actually what we'll do is we'll make it outside of this because it seems to not like the way I was trying to do it. So we'll open up terminal. Let me just open a new tab here. And we'll change this to VPN. All right, and we'll make it right here. I'm just gonna call it nano. We'll call it colors.text. And let's just think of some colors like on a rainbow. So we have orange, green, purple, red, yellow, RGB, red, green, blue. Do I have blue? Blue. We'll just start with like the normal colors I can think of and not weird colors like what you find on crayons. Let's go ahead and save that. And now, if we go to this, we can do hosted file, and we should actually be able to upload our file here. Oh man, Kato's failing me. What is going on here with Kato? Come on, Cato, I believe in you. Hold up. Just going to try to reopen it real quick. I was just bragging about Cato, and now it's not working for me. I've never had this specific issue before, though. Let me try it one more time. So if I go to Files, I'm not doing anything wrong, am I? Browse. Why? Why do you crash? That makes me sad. Okay. Let me try it one other way. Oh, you must create... Oh, is that all I'm doing wrong? Hold up. Okay, I'm going to try it one more time. If I go to Files... Dang it. Well... I might have to switch over to Burp Suite, unfortunately. Yeah, now it's like really bugged out on me. Now Cato's crashed and it's not even opening. Address is already in use. I wonder, let me try this. Let me try one more thing. Actually, so I'm using that. Let me try Firefox. If I do... Is it 8080? Sit tight. I'm going to stop sharing my screen just for a second while I log in. It may just be something with a Chromium browser that it doesn't like. I'm not sure. We're going to find out, though. We'll see if it works in Firefox. Okay. Now we are here. Let's just see what happens if I go to Files and Browse. Gosh. Something, now I'm curious, is it, I'm using WSL, and I had a weird issue with WSL and importing certificates. So like importing a certificate into Chrome, I had to do it via a weird command line way. I wonder if it's something weird with WSL that it doesn't like for some reason. Here, I actually am very curious about testing this. So we're going to switch back over to this, and we're going to get out of WSL. Hang tight with me for like 30 seconds, and I'll be back to sharing my screen. I'm opening it in VirtualBox now. I really think it's something weird with WSL that might be going on here. We'll see if my theory is correct, though. All right, I will go back to sharing my screen. Yeah, dude, I was running a GUI in WSL. I think that may have been the issue. It didn't like that. All right. Back on that. Let's name this one Cato. All right, we got Cato pulled up. Let me log in real quick. Yeah, I usually, like, if I need a GUI at work, I just find that WSL with the GUI, or WinKex, I think is what it's called, in the Kali documentation, just works a lot better than a virtual machine. And so that's how I generally use it, but I don't usually stream that way. So I've had some weird issues using the GUI in WSL, but generally speaking, it usually works pretty well. But every once in a while, I have weird issues like what I just had. I'll go back to share my screen in just a moment. Okay, intercept. There we go. Here's my screen. Now, let me go ahead and pull up Firefox. We'll throw that over here. And I'm going to grab that TryHackMe room actually from the chat. One second. Okay, we're back in business. Let's see what happens now. If I open up this, nano colors.txt, what did we say? Red, blue, orange, purple, green, yellow. Let's just begin with that. I wanted just to see if I can import it. Files, browse. Yeah, there you go, guys. I'm almost certain it's something weird with WSL, not something weird with Kato. So use Kato. It's awesome. Let's see. TryHackMe, OWASP, colors. Okay, so now that we have that, now we should be able to minimize this. Go down to this guy right here. Copy link. Pull this up. Burp sleep, but really we're using Kato. Oh, now it doesn't want to connect to this IP. This is the beauty of live streaming. Everything goes wrong when you live stream. Do I need to get mine a different IP than I was before? Let's try this. Okay. Was my old connection still on? Hold up. Do. 1 second. I'm logging into WSL now. I thought I killed it, but maybe I didn't. Oh, it's still on there. Okay, I bet that might be my issue. So we're going to do kill 9. Kill 924 652. Doesn't want to die. Well, it was not a VM. Yeah, that's what I'm doing this kill 9. I killed like, there was 4 open VPN processes and it allowed me to kill 3 of them, but one's still there. And I'm not sure why. Should have sudo it. Okay, well, let's just see if that fixed it. So what I was using before, in the previous box, you're using a VM. I wasn't technically using a VM. So what I was using is what's called WSL, which is Windows Subsystem for Linux, I think is what it stands for. And it runs actually off the hardware on your computer, I believe, instead of being like fully virtualized. There we go. I fixed it. And so that's what I was using. And it's what I use at work. But usually, like when I'm doing a pen test, I actually connect to the VPN through my host computer, which is Windows, not through my VM or through WSL. But even then, like most of the time at work, I'm not even using a GUI. If I need Linux, I'm just popping up WSL and we're good. But I got it, guys. I just said I killed the process and I'm on there now. So should be good to go. See? I do want to make sure I have this set up. Okay, beautiful. So back in business now. The beauty of live streaming is you get to watch me troubleshoot weird issues. So let's go and do Joseph. Continue. Why don't I use the attack box? Because then I would have to install Cato on the attack box every time I use it. That's why. I do use the Pwn box sometimes and hack the box. I don't know if you guys know this, but the Pwn box has a user init script that you can configure. So on my Pwn box and hack the box, I have it in the user init script that it goes out and downloads Cato and configures everything for me. So each time I open the Pwn box, Cato is pre-configured. TryHackMe does not have that option on the attack box. All right, favorite color, we'll say red. Turn on this. Go ahead and click continue, and we'll send that over to automate. And then on automate, we will mark that, the thing that we want to brute force, and our selected file will be colors, and we'll go ahead and hit start. Shouldn't take too long. And if we sort it by length, we can see that green has a different length than the other ones. And if we go to green, we can say, hey, here is our request for green. And we got a 302 found. And you can see this one is giving us an error. These are all giving us errors, whereas green, green is sending us to reset past 3. So we know the correct answer there is going to be green. So let's go ahead and forward that. Turn off queuing. And there we go. The password for user Joseph has been reset to that. So let's go ahead and grab his password. We'll go back to login. And we will do Joseph and log in. We have private cat images. Well, there's our flag. What's our cat images? Let's see the cat images. Monorail cat. Beautiful. They told me I could be anything, so I became a cannonball. Heck yeah. Well, here's our flag. Not even the cats could save you. There we go. Took me a little bit because of my weird WSL setup, but hopefully you guys learned something in the process. Security misconfiguration. Let's dive into this one. Security misconfigurations are distinct from the other top 10 vulnerabilities because they occur when security could have been appropriately configured but was not. Even if you download the latest up-to-date software, poor configurations could make your installation vulnerable. Security configurations include poorly configured permissions on cloud services like S3 buckets, having unnecessary features enabled like services, pages, accounts, or privileges, default accounts with unchanged passwords happens more often than you would think, error messages that are overly detailed and allow attackers to find out more about the system, and not using HTTP security headers. Where's that link to? Okay. This vulnerability can often lead to more vulnerabilities, such as default credentials giving you access to sensitive data, XML external entities, or command injection on admin pages. For more info, look at the OWASP top 10, etc., etc. So debugging interfaces. A common security misconfiguration concerns the exposure of debugging features in production software. Debugging features are often available in programming frameworks to allow the developers to access advanced functionality that is useful for debugging an application while it's being developed. Attackers could abuse some of those debug functionalities if somehow the developers forgot to disable them before publishing their applications. One example of such a vulnerability was allegedly used when Patreon got pwned in 2015. 5 days before Patreon was hacked, a security researcher reported to Patreon that he had found an open debug interface for a work Zerg console, which is Python. It is a vital component in Python-based web apps as it provides an interface for web servers to execute the Python code. So you can kind of see how this would be a bad thing. It includes a debug console that can be accessed either via URL on console, or it will also be presented to the user if an exception is raised by the application. In both cases, the console provides a Python console that will run any code you send to it. For an attacker, this means he can execute commands arbitrarily, which, bad idea. Practical example. So the VM showcases security misconfiguration as part of the OWASP top 10. We'll go ahead and open that in a new tab. So it says navigate to there to get the console. So it's a Flask to do app, which means we could probably look at app.py as well and get some cool stuff. Actually, let's go back to the to-do list. Just want to see, like, do we have cross-site scripting on here? First, let's try HTML injection. Please subscribe. Okay, no, it doesn't. What if I update? So it probably isn't vulnerable to your typical like alert one. Actually, real hackers do alert 1337. Okay, interesting. Not going to spend a whole lot of time on that. So, hey, we have in this console can execute Python expression. So we did it complete. Using it to run the following Python code to execute LSL command on the server. So here's what it's going on for those of you who might be kind of new to Python. In Python, you can import OS, which allows you to run system commands. Generally speaking, it's not something you want to use in production. If you do ever use anything like this in production on a web app, you definitely do not want to pass user input into OS commands, because that's how you get RCE on an application. And you can see it's importing OS, and then if you're picturing a Python script, this would be like at the top, and then down below that is just giving us a very simple print function, and we're printing out to the console, of course, your typical LS, and then reading it. So if we type this in, we can see, hey, we are reading app.py requirements templates to do. And that is what's going on there. So it says, what is a database file that want the DB expression in the current directory? You can see to-do.db. I'm immediately testing a reverse shell here. Yeah, dude, it'll work, I'm sure. Modify the code to read the contents of the app.py file, which contains the application source code. Right, so that's what I was even saying. I said, hey, if there's an app.py, I've seen this on a Hack the Box machine, actually. It's like initial access. You got, I think, LFI or something, and then you read app.py, and you're able to get, I think it was hard-coded creds. I don't actually remember what it was, but I remember app.py from that in particular. So if we want to read that, we could just do, right, hit enter. And it says there's some secret here. Oh, just a tiny misconfiguration. And at Hackers Corners Inspiration, let's also see, even though it's not required, let's see if we can get a shell on here. So if we pull this up, we do something like, oh, not that. Okay. Something simple like that. Oh, I need to do the port though. Of course, as hackers use port 1337. There we go. So there's my shell right away. Oh, I broke it by trying to go to root, but there we go. So just showing that we could also use that debug console to get a full RC, to get a full reverse shell on the machine. There was our extra credit since it wasn't required, but there you guys go. Vulnerable and outdated components. Occasionally, you may find that the company or entity you're pen testing is using a program with a well-known vulnerability. For example, let's say that a company hasn't updated their version of WordPress for a few years, and using a tool such as WP Scan, you find that it's version 4.6. Some quick research will reveal that WordPress 4.6 is vulnerable to an unauthenticated remote code execution exploit, and even better, you can find an exploit already made on ExploitDB. As you can see, this would be quite devastating because it requires very little work on the attacker's part. Since the vulnerability is already well known, someone else has likely made an exploit for the vulnerability already. The situation worsens when you realize that it's It's super easy for this to happen. If a company misses a single update, it could be vulnerable to any number of attacks. And you can imagine large companies with so many different apps, so many different programs running across the board. You really do need a team dedicated to that. Actually, at my previous job, I worked at a large bank, a large financial institution, and that was the majority of my job was vulnerability management. We would use Nessus to scan our environment, see things that were out of date, and then we would work with the different teams to make sure we could patch it without breaking things. We think that, hey, just patch your software, super easy to do, but there's so many different pieces that sometimes by patching it, you're going to break something. So then you have to put in other security measures to stop that from being exploited. So it's just a lot more difficult than we just think as pen testers. Just patch your stuff. It's not usually that easy in the real world in production. I have used OpenVAS, but only in labs. In my last job, like on the blue team, as well as my current job as a pen tester, I use Nessus just because the companies I work for have a license for it. But I have used OpenVAS, but I think only in a TryHackMe lab. Also in Hack the Box Academy, I think they go through that as well. All right, now we're going to exploit it. Recall that since this is about known vulnerabilities, most of the work has already been done for us. Our main job is to find out the information of the software and research it until we can find an exploit. Let's go through that with an example web application. So we have Nostromo 1.9.6. What do you know? The server has a default page for the Nostromo web server. Now that we have a version number and a software name, we can exploit DB to try and find an exploit for this particular version. Lucky us, the top result happens to be an exploit script. Let's download it, try to get code execution. And it says running it teaches us an important lesson. It says, hey, you have an issue with your Python script that is not defined. Exploits you download from the internet may not work the first time. And I will just say, like when you're doing a real pen test, don't just fire off exploits from GitHub. That is a good way to get the customer very mad at you, right? Exploit DB is pretty trustworthy, but even then you should always read the exploit before you just randomly fire it off. It helps understand the programming language the script is in so that, if needed, you can fix any bugs or make any modifications, as quite a few scripts on ExploitDB expect you to make modifications. Fortunately, the error was caused by a line that should have been commented out, so it's an easy fix. Oh, there you go. Fixing that, let's try and run the program, and they do. They try to run ID, and we can say, hey, it worked. Boom, we have RCE. Now, it's important to note that most scripts will tell you what arguments you need to provide. Exploit developers will rarely make you read potentially hundreds of lines of code just to figure out how to use a script. It's also worth noting that it may not always be this easy. Sometimes you'll be given a version number, like in this case, but other times you may need to dig through the HTML source or even take a lucky guess on an exploit script. One cool way I've seen version enumeration happen was actually on IPSec. I was watching IPSec work through some Hack the Box machine, and he needed to figure out the version information, but there was no information on the web app. What IPSec did is he went to like the JavaScript files, and he took the JavaScript files and hashed them so he knew the specific hash of that specific JavaScript file. Then he went to the GitHub for this open source project and went through the different versions and downloaded the same JavaScript file from the different versions, hashed those, and then he did a compare between all the different JavaScript versions of that file and the one that was running, and he found the correct hash in GitHub, and then he was able to use that information looking at the releases. Then he knew the version information, and from that was able to research an exploit. I've never seen version enumeration done that way, but that is genius. So kudos to IPSec. I never would have thought about that myself, but that's one other way you can look for version enumeration. A very cool way to do it. That's really it. The great thing about this piece of the OWASP Top 10 is that the work is already done for us. We just need to do some basic research, and as a pen tester, you're already doing that quite a bit. All right, here's our lab. Navigate to that and pwn it. All right, let's go and open that link in a new tab. And let's do a little bit of enumeration. Welcome to the online CSE bookstore. This site has been made using PHP with MySQL procedural functions. The layout used Bootstrap to make it more responsive. It's just a simple app. So we have some latest books here. And does it actually open anything? Oh, it does. Can we actually buy it? Look at that. We can actually check stuff out. But I already see a few things that stand out to me, even though I'm kind of clicking around the app. is, of course, we have admin login and we have project worlds, which must be some type of thing that was used for this. And we have CSE bookstore. We even have a year information here. What's our contact page? Beautiful. Okay, so if we go with the information that we have, oh, did that work? Did I just log in as an admin? Okay. I did. Look at that. I didn't even mean to do that. I just did admin because I like to try that randomly, and it worked. But okay. Project worlds and admin. So if we just do like project. Here we go. I bet this is it. We have this online bookstore unauthenticated remote code execution by the one and only Tiberius. Yo, Tiberius just got hired at TCM Security as a mix of web app pen tester and content creator. Exciting stuff. So he is the exploit author of this. And we can see it's looks like a pretty simple Python script. We're importing our libraries up here, and we have this argument that the script's going to receive. So if we run it without anything, it's going to say, hey, you need to provide this argument for a URL, and it's going to be the URL of the target. Looks like we're doing a random file. We're pending that, and it's just uploading. We're just bypassing authentication and uploading a very simple PHP reverse shell, or not reverse shell, just web shell, it would appear to me. And then you can do any type of web shell type stuff. It's going to say web shell uploaded to. It's going to pass it our URL, bootstrap, image, and then the random file name. So blah, 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 .php. And if we go to that, we're going to be able to execute commands. All right, so let's just go ahead and copy this. .py. It's obviously what I would call it. So if we just run it without anything, it's going to say, well, ignore this. It's because I broke my Python in some ways. But it says the following arguments are required, the URL. So if we do pwn.py and we just pass it the URL, which would be this right here. Look at that. We have command execution. What is the content of opt? But it's not my fault. Beautiful. All right. Let's keep going. We are going to talk about identification and authentication failures. Authentication and session management constitute core components of modern web applications. Authentication allows users to gain access to web apps by verifying their identities. The most common form of authentication is using a username and password mechanism. A user would enter these credentials and the server would verify them. The server would then provide the user's browser with a session cookie if they are correct. A session cookie is needed because web servers use HTTPS to communicate, which is stateless. Attaching session cookies means the server will know who is sending what data. The server can then keep track of users' actions. Hopefully the attack path is coming in your mind. If an attacker is able to find flaws in an authentication mechanism, they might successfully gain access to other users' accounts. This would allow the attacker to access sensitive data depending on the purpose of the application. Some common flaws in authentication mechanisms include the following. Brute force attacks. If a web application uses usernames and passwords, an attacker can try to launch brute force attacks that allow them to guess a username and password using multiple authentication attempts. This is something that I check when I am doing a web app assessment, is just, hey, are brute force attacks possible? Generally speaking, accounts should either be locked and requests should be rate limited to prevent brute force attacks, but much of the time they're not, and you can just demonstrate that to a client by throwing it in like Burp Suite Intruder and doing like 50 or 100 attempts and then providing the correct password at the end, just showing as a proof of concept brute force attacks are possible. Use of weak credentials. Web applications should set strong password policies. If applications allow users to set passwords such as password 1 or common passwords, an attacker can easily guess them and access user accounts. Another thing that we check on web app assessments is the password policy. First, we'll start by like, hey, can I set my password as P? Can I set my password as password 1? Just looking like, can I set a weak password? And if so, that's an informational or maybe low finding saying, yo, don't have terrible password policy. And weak session cookies. Session cookies are how the server keeps track of users. If session cookies contain predictable values, which you can send in burp to synchronizer. Am I thinking of the right word? Anyways, it pulls a bunch of them and compares them. Attackers can set their own session cookies and access users' accounts. There can be various mitigation for this depending on the exact flaw. To avoid password guessing attacks, ensure a strong password policy. To avoid brute force attacks, ensure it enforces automatic lockout after a certain number of attempts, which I just said. And implement MFA. That is huge, but remember, MFA can always be bypassed with simple phishing attacks. Humans are always the weakest link. If a user has multiple authentication methods, for example, using a username and password and receiving a code, it would be difficult, but not impossible, for an attacker to get both the password and the code to access the account. All right, I've understood broken authentication mechanisms. We'll say yes. Now we're going to do our lab. Let's open this, close out some of these extra ones that we have here, and get trusty Cato pulled up. It says, for this example, we'll look at a logic flaw within the authentication mechanism. Many times what happens is that developers forget to sanitize the input, or username and password, given by the user in the code of their application, which can make them vulnerable to attacks like SQL injection. However, we will focus on a vulnerability that happens because of a developer's mistake, but is very easy to exploit, i.e. re-registration of an existing user. Oh yeah, like there's already an admin, you register as admin. Let's understand this with the help of an example. Say there's an existing user with the name admin, and we want access to their account. So what we can do is try to re-register that username, but with a slight modification. We'll enter admin without the quotes, and notice this space right here. Now, when you enter that in the username field and enter other required information like email ID or password and submit that data, it will register a new user, but that user will have the same right as the admin account. That new user will also be able to see all the content presented under the user admin. To see this in action, go there, try to register with Darren, and then you'll see it already exists. All right, so we're going to try to take over Darren's account. So if we go to register, if I just do Darren without any type of space, it's not a real email, don't email it, and password 123, that's of course same password for my bank account there. The user is already registered. Once again, we have some username enumeration there. So we'll go to register and we'll do, space Darren. I'm a elite hacker. Password 123. Okay, and now we'll do space Darren. Password 123. Okay, we got logged in as Darren. We bypassed authentication right there. We found the flag. Now try the same trick and see if we can log in as Arthur. All right. Register, do space, Arthur. I don't know how to spell, obviously. Beautiful. Easy enough. SATA software. Oh, did I miss something? There we go. Software and data integrity failures. What is integrity? Well, when talking about integrity, we refer to the capacity we have to ascertain that a piece of data remains unmodified. Integrity is essential in cybersecurity as we care about maintaining important data for, remember the CIA triad, those security plus people, you should have that memorized, right? Confidentiality, integrity, and availability. So it's integrity. For example, say you're downloading the latest installer for an application. How can you be sure that while downloading it, it wasn't modified in transit or somehow got damaged by a transmission error? Think of like a supply chain attack. To overcome this problem, you will often see a hash sent alongside the file so that you can prove that the file you downloaded kept its integrity and wasn't modified in transit. A hash or digest is simply a number that results from applying a specific algorithm over a piece of data. When reading about hashing algorithms, you will often read about MD5, SHA-1, and SHA-256, or many others available. Let's take a drink. Let's take WinSCP as an example to understand better how we can use hashes to check a file's integrity. If you go to their source Forge repository, you'll see that each file to download probably has a hash. Yeah, we can see our hashes there. These hashes were pre-calculated by the creators of WinSCP so that you can check the file's integrity after downloading. If we download the file, we can recalculate the hashes and compare them against the ones published in SourceForge. To calculate different hashes, we can use the following commands, right, depending on the hash that we want to get. Since we got the same hashes, we can safely conclude the file we downloaded is an exact copy of the one on the website. This vulnerability arises from code or infrastructure that uses software or data without using any kind of integrity checks. Since no integrity verification is being done, an attacker might modify the software or data passed to the application, resulting in unexpected consequences. There are mainly two types of vulnerabilities in this category: software integrity failures and data integrity failures. Yeah, check, Reddit. Software, all right, looks like we're getting into a lab, possibly. A very minor one, it looks like. Suppose you have a website that uses third-party libraries, which almost all websites do, that are stored in some external servers that are out of your control. While this may sound a bit strange, this is actually a somewhat common, I'd say really common, not just somewhat, but super common. Take as an example jQuery, a commonly used JavaScript library. If you want, you can include jQuery in your website directly from their servers without actually downloading it by including the following line in the HTML code on your website, right? When a user navigates to your website, its browser will read its HTML code and download jQuery from the specified external source. The problem is that if an attacker somehow hacks into the jQuery official repository, they could change the contents to inject malicious code and pwn a bunch of websites. As a result, anyone visiting your website would now pull the malicious code and execute it into their browsers unknowingly. This is a software integrity failure, as your website makes no checks against a third-party library to see if it has changed. Modern browsers allow you to specify a hash along the library's URL so that the library code is executed only if the hash of the downloaded file matches the expected value. The security mechanism is called sub-resource integrity, and you can read more about it here. Let's check this out. So we can generate integrity hashes, and then we can include it in our source code. And it says, hey, if the hash doesn't match whatever we put here, it will reject it, I'd assume. The correct way to insert the library into your HTML code would be to use SRI, which is that, and include an integrity hash so that if somehow an attacker is able to modify the library, any client navigating through your website won't execute the modified version. Here's how that should look in HTML. Yo, what up, Mike Firo? Good, dude. Thanks for hanging out with me. So we can see this, we're passing it integrity. And just to show you like how common this is, let's go to, if we look at TryHackMe.com, and if we just look at like page source here, you can see they're actually not doing, no, that's their own website. That's their S3 bucket right there. But you can see we have some Cloudflare stuff. Here's one. We have this Font Awesome one, third party, but you can see they did include the integrity check right there. Whoops. But just to give you an example of what this might look like in the real world. Often when I see this, people don't include the integrity check. I don't really report it because I think it's so unlikely for it to happen. But hey, it's still something to be aware of. We could probably keep looking through this if we wanted to, but probably not something you could report on a bug bounty and get like money for, but still good to be aware of, especially depending on what it might be pointing at. I also think there is a TryHackMe room my friend Amoeba Man made. Oh, I can't think of what it's called, but it actually demonstrates a supply chain attack in this way by hijacking, I think it's an S3 bucket that expired, taking over the S3 bucket, and then hosting a malicious script to steal usernames and passwords, but I can't think of what the room's called off the top of my head. But if you find it, check it out. So our question is just getting the SHA-256 code of this. So if we were putting into a website, we would include that SHA-256 and then the hash that we get here, and we can get that right here. Oh, change it to 256 though. It actually gives us the full HTML to include, so that's helpful. I'm sure you can make like an API call out to that too to automate the process. There we go. Data integrity failures. Let's think of how web apps maintain sessions. Usually, when a user logs into an application, they will be assigned some sort of session token that will need to be saved on the browser for as long as the session lasts. This token will be repeated on each subsequent request so that the web application knows who we are. These session tokens can come in many forms but are usually assigned via cookies. Cookies are key value pairs that a web app will store on the user's browser, and they'll be automatically repeated on each request to the website that issued them. For example, if you were creating a webmail app, you could assign a cookie to each user after logging in that contains their username. In subsequent requests, your browser would always send your username in the cookie so that the web app knows what user is connecting. This would be a terrible idea security-wise because, as we mentioned, cookies are stored on the user's browser, so we could tamper with it and change it. They could potentially impersonate someone else and read their emails. This application would suffer from a data integrity failure as it trusts data that an attacker can tamper with, right? Thing I tell clients in debriefs is you never trust client-side code. Like if it can be modified by the user, you don't trust it. You always verify on the server side of things. One solution to this is using some integrity mechanism to guarantee that the cookie hasn't been altered by the user. To avoid reinventing the wheel, we could use some token implementations that allow you to do this and deal with all the cryptography to provide proof of integrity without you having to bother with it. One such implementation is JSON Web Tokens. Okay, guys, I recently learned JWT, that's how I say it, is pronounced JOT. Does anyone in chat pronounce JWTs as JOTs? Because that just sounds weird to me. I'm going to call it JWTs. I know it's not technically correct, but I don't care. JWTs are very simple tokens that allow you to store key value pairs in a token that provides integrity as part of the token. The idea is that you can generate tokens that you can give your users with the certainty that they won't be able to alter the key value pairs and pass the integrity check. The structure of a JWT token is formed in three parts. We have the header, the payload, and the signature, just base 64 encoded. The header contains metadata indicating this is a JWT or JOT, and the signing algorithm in use is HS256. The payload contains the key value pairs of the data, usually the username and expiration, that the web app wants the client to store. The signature, right there, is similar to a hash taken to verify the payload's integrity. If you change the payload, the web application can verify that the signature won't match the payload and know that you tampered with the JWT. Unlike a simple hash, this signature involves the use of a secret key held by the server only, which means that if you change the payload, you won't be able to generate the matching signature unless you know the secret key, or there's some CVEs I bet it's going to talk about. Notice that each of the three parts of the token is simply plain text encoded with base 64. You can use this online tool to encode or decode. What's this? No, I'm going to show you guys a cooler tool. JWT.io is cooler. This is what we'll use. All right. Blah, blah, blah. JWT and the none algorithm. Yep, this is where I thought it might be going to. A data integrity failure vulnerability was present on some libraries implementing JWTs a while ago. Actually seen this in the real world. As we have seen, JWT implements a signature to validate the integrity of the payload data. The vulnerable libraries allowed attackers to bypass the signature validation by changing the two following things in a JWT. They modify the header section of the token so that the alg header would contain the value none, and you remove the signature part. In Burp Suite, I believe it's limited to Burp Suite Pro, there is a plugin that allows you to do this. Like, I think it's called, it might just be called JSON Web Tokens, where you can capture the requests and kind of modify and intercept things that way. So how do we do it? You modify the header section so the alg header would contain the value none, and you just remove the signature. Taking the JWT from before as an example, if we wanted to change the payload so that the username becomes admin and no signature check is done, we would have to decode the header and payload, modify them as needed, and encode them back. Notice how we removed the signature part but kept a dot at the end. So you can see we have the header and the payload, but no signature. It sounds pretty simple. Well, let's walk through the process an attacker would have to follow in an example scenario. Navigate to that and follow the instructions in the questions below. Close some of my extra tabs. Cookies for all. Try logging into the application as a guest. What is the guest account's password? Well, we are going to try guest because that I seem to be getting lucky with that. We'll go ahead and capture this. And there it is. I'm going to send that to replay, but if we forward that, did I get logged in? Hello, guest. Only the admin user is allowed. And if we send this, it's giving us this JWT session, which I bet if we decode this, this is the guest session. Yep, so you can see our guest. So we're going to try to change that to admin, and we'll strip away the signature and change the ALD to none. What's the question, though? Guest. Oh, let me turn off intercept. My bad. If your login was successful, you should now have a JWT stored as a cookie in your browser. Press F12 to bring out the developer tools, blah, blah. And yeah, we'll do that, but you can also just see it here. When we have a successful login, it's setting our session right there. What is the name of the website's cookie? It is just JWT session. Use the knowledge gained in the task to modify the JWT so that the application thinks you are the user admin. So, whoops. I don't know what I just did to that. Let's grab this. Actually, well, I'll show you guys a tool. Change this to admin. Of course, this won't work because we haven't updated the alg. Now, this is a pretty simple example. We could do it manually, but I want to show you guys a cool tool that I have found helpful. We can exit out of this. I don't know if I have it. JWT tool, I think it's called. Okay, let's go ahead and download it from GitHub. Okay, JWT tool, let's grab this code and we'll just clone it. CD JWT. Install our requirements. Okay. Okay, beautiful. So with this tool, we can automatically generate some of these payloads. Now ours, once again, is simple, but want to show you a little bit about this tool. If you are testing a JWT token, you can do a lot of cool things with this. And for us, we want to do the none algorithm. And I believe there's like an exploit. Let's see. We're going to exploit, here we go. So then we can give it, if we give it exploit A, algorithm none, and that's what we want to do. So I think if I do like exploit A and then pass it that, nope. I'm gonna pass it the token where I already modified it to admin right here. Oh, did I do something wrong? Maybe I need to go like that first. There we go. So you can see, hey, here's what we did, our original JW2, and then exploit alg none. This is an exploit targeting the debug feature that allows a token to have no signature. This will only be validated on unpatched implementations of JWT. Now, sometimes, hey, none doesn't work, so none works, or none works, so that weird none works. Let's just grab this one. And you can actually see it's following what TryHackMe talked about. Here we have the header. Here we have the payload. And it ends at that period. We have no signature. So if we go ahead and just copy this and drop it in jwt.io, you can see we have none, invalid signature. But hey, if it doesn't actually check that, then that's going to be okay. So now if we go to more tools, web developer tools, memory, or storage, I should say, and we have our JWT session right here. If I just update that, and there we go. We became admin We abused the insecure JWT and made ourselves the admin. Awesome. We have, looks like some task files here. Let me just get those downloaded. I don't know what that file was called. Login logs. Okay, so what do we see in our login logs here? It looks like we have this IP address and they are trying to, looks like a brute force attack, login as root, anonymous administrator admin. But let's see what the task talks about. Web applications are set up. Every action, or when they're set up, every action performed by the user should be logged. Logging is important because in the event of an incident, the attacker's activities can be traced. Once their actions are traced, their risk and impact can be determined. Without logging, there would be no way to tell what actions were performed by an attacker if they gain access to particular web applications. The more significant impacts of these include regulatory damage. If an attacker has gained access to personally identifiable user information and there's no record, final users are affected, and the application owners may be subject to fines or more severe actions depending on regulations. And finally, risk of further attacks. An attacker's presence may be undetected without logging. This could allow an attacker to launch further attacks against web app owners by stealing creds, attacking infrastructure, and more. The information stored in logs should include the following: HTTP status codes, which we have in this log here. We have timestamps as well. We have usernames, API endpoints, or page locations, and IP addresses. So this log has all of that. These logs have some sensitive info, so it's important to ensure they are stored securely and that multiple copies of these logs are stored at different locations. As you may have noticed, logging is more important after a breach or incident has occurred. The ideal case is to have monitoring in place to detect any suspicious activity. The aim of detecting the suspicious activity, so kind of like a little bit of threat hunting, which TryHackMe is in a whole threat hunting week, coming out with new rooms about threat hunting all week. Cool stuff. Is to either stop the attacker completely or reduce the impact they made if their presence has been detected much later than anticipated. Common examples of suspicious activity include multiple unauthorized attempts for a particular action, usually authentication attempts or access to unauthorized resources such as admin pages, requests from anonymous IP addresses or locations. We're looking at you, Russia. While this can indicate that someone else is trying to access a particular user's account, it can also have a false positive rate. Use of automated tools, particular automated tooling can be easily identifiable using the value of user agent headers or the speed of requests. This can indicate that an attacker is using automated tooling and common payloads. In web apps, it's common for attackers to use known payloads. So you think of like your typical SQL injection bypass, stuff like that. Detecting the use of these payloads can indicate the presence of someone conducting unauthorized or malicious testing on applications. Just detecting suspicious activity isn't helpful. The suspicious activity needs to be rated according to the impact level. For example, certain actions will have higher impact than others. These higher impact actions need to be responded to sooner, thus they should raise alarms to get the relevant party's attention. Put this knowledge to practice by analyzing our file, which we already kind of did. What IP address is the attacker using? Quite certain this is our attacker right here. Drop that in. What kind of attack? I think a brute force attack. Look at that. I'm just so good. All right, SSRF. One that I think isn't talked about enough, but a very cool exploit, especially on the cloud side of things. And hey, we're also almost done with this little room, so that's exciting. This type of vulnerability occurs when an attacker can coerce a web application into sending requests on their behalf to arbitrary destinations while having control of the content of the request itself. I've seen this multiple times in the real world, including being able to launch like a port scan on an internal environment. Cool stuff. SSRF vulnerabilities often arise from implementations where our web apps need to use third-party services. Think, for example, of a web application that uses an external API to send SMS notifications to its clients. For each email, the website needs to make a request to the SMS provider's server to send the content of the message to be sent. Since the SMS provider charges per message, they require you to add a secret key which they pre-assign to you to each request you make to their API. The API key serves as an authentication token and allows the provider to know to whom to bill each message. The application would work like this. So you can just see, hey, if we update that server to us, it might send us that secret code essentially. So send request, build query, forward SMS provider using the API key. So if you can pretend like you're the SMS provider, you get the API key. By looking at the diagram above, it's easy to see where the vulnerability lies. The application exposes a server parameter to the users. It's usually not that obvious, but sometimes it can be, which defines the server name of the SMS service provider. If the attacker wanted, they could simply change the value of the server to point to a machine they control, and your web app would happily forward the SMS request to the attacker instead of the SMS provider. As part of the forwarded message, the attacker would obtain the API key, allowing them to use SMS service to send messages at our expense. To achieve this, the attacker will only need to make the following request to the website. You can see that's their IP. This would make the vulnerable web make a request to them, and then they would be able to capture that secret IP or whatever. This is really a basic case of SSRF. If this doesn't look that scary, SSRF can actually be used to do much more. In general, it can be used for this. I have done this before in the real world, enumerate internal networks with SSRF. Abuse trust relationships, interact with non-HTTP services, and one that I would add is being able to steal AWS credentials. Let me just show that to you guys, because I think SSRF is not complete without a conversation about that. It actually affects all of the cloud providers, but AWS is the most known one. EC2s are the way AWS talks about virtual machines. So often a company will use an EC2 to run a web server, and if you can get SSRF on that web server, because it's an EC2, if things are not configured properly, you can actually make a request to a endpoint, an AWS endpoint, a 169. You can see it's not a public IP, but almost kind of like localhost for AWS in some ways, and you can make a request to that, and you can actually hunt down credentials that you can then pivot into the AWS environment. I have actually multiple videos on my YouTube channel where I demonstrate this in action through CloudGoat scenarios, as well as to the attacking and defending AWS pathway on TryHackMe. Quick note for my YouTube channel. Let me see if I can grab this link right here. I think that link works, although it looks different than normal. Yeah, it does. Okay. So if you click that link, I have an entire playlist, like a 20 video playlist on attacking and defending AWS. I did the full TryHackMe pathway that's limited, like most people can't do it, streamed every part of it. And in that pathway, we actually abuse this in one of the scenarios to get SSRF. So check it out on my YouTube channel, go to playlist, and you should be able to find that where I demonstrate this. But you can see what it's doing. It is SSRF request to that endpoint, and you eventually dig down into it, and you can get the access key ID, the secret access key, and the token, and then you can infiltrate into the AWS environment. Cool stuff. So if I was rewriting this room, I would just tell TryHackMe, hey, include just a little bit about cloud stuff here, because I think that really ups what SSRF can do if you can infiltrate the AWS environment of the client. 8-bit only. Cool, man. I have also an entire playlist just pen testing AWS. The firm that I work for, the one and only Rhino Security Labs, we have come out with a tool called CloudGoat, which allows you to deploy vulnerable AWS infrastructure. Matter of fact, you know, we're going to pause right here. I want to share with you guys a room I created. It's not an official TryHackMe room because it requires you to set up your own environment, and I'm actually going to stop sharing my screen so you guys can't see my other CTFs I'm working on. But I created a few rooms that introduce you to CloudGoat. It actually teaches you how to set up CloudGoat all the way from like having no AWS experience. It walks you through creating a free tier AWS account. Then it walks you through configuring CloudGoat and your Kali Linux machine so it's ready for AWS pen testing. So let me actually drop these links right here in the chat. So that first link is intro to CloudGoat. Actually, I dropped the wrong one. Let me click share room. That one that I just gave you won't work. There. That one is an intro to CloudGoat room that I created that will guide you through that process step by step, even without any AWS experience. And then this second room is a walkthrough of this specific scenario that we're talking about. We have an EC2 to SSRF scenario, and in that room, let me just grab it real quick. I teach you how to do that in the CloudGoat scenario so that you can get some experience with it. So here's the room that I created. I wonder how many people have gone through this. So 190 users are here. So if we look at this, I guide you through launching the scenario, and we even go through the whole process of using SSRF on a vulnerable web application that it launches in order to get those credentials. We get those credentials, we hunt through some S3 buckets, and we execute our goal, which is invoking a Lambda function. But I explain Lambda functions, I explain SSRF, I explain EC2s, all in that room. So check it out. If you find it helpful, share it with other people. But those rooms are all free to use. You don't need a TryHackMe subscription or anything like that. Whoops. You guys saw my developer page, but there wasn't a whole lot there, at least on that specific screen. Okay, what am I doing? Okay, we're abusing SSRF. All right, let's see if we can do this. So after exploring a bit, you should see an admin area, which will be our main objective. Follow the instructions to gain access to the website's restricted area. Dude, 282 day streak. Nice, man. Hi, John Woo. Let's get Kato pulled up here. And it says, we have John Woo, cat photographer and web designer. Look at his beautiful portfolio. Hi there, I'm John. I work as a cat photographer. I graduated from cat photography school at the age of 22. Man, I bet the dude's a millionaire, and I've been taking pictures of them ever since. If you have a cat and you need to get it into a frame, I'm the man for the task. Are you looking for a dog photographer? Well, it was nice meeting you. My skills: photography 75%, web design 65%, enthusiasm 110%. What has he done? 140 plus cats, 55 plus projects, 41 happy clients. So if we do the math, not all the clients were happy, I don't think. And 356 plus photos taken. We have that. We have this download resume. That seems to be the only button, right? Oh, we have this. Okay, here's the admin area. So only available from local hosts. So we need to find SSRF so that we can access this. And the only thing I see is this download resume. So if we turn on queuing. Oh, so we have something very similar here to what they actually talked about in the example. We have download server, and then we're giving it a server. So if I pull this up, and we'll do netcat mvlp 1337. And what if instead of that server, we do 10.13.4.234 1337 like that? There you go. So it's making that request. Rather than downloading his resume, we just set ourselves up as, hey, we are that server, and it's now passing us the API key. And you can see that there. We'll go ahead and grab that. Very basic example, but good example nevertheless of SSRF. Oh, maybe I should answer these questions. So that's localhost. If I would turn off intercept. Oops. Oh, so there's his actual resume because I forwarded that original request. Where does the server parameter point to? Well, it points to initially on its own. I think this is what it's looking for, but let me copy the flag in first. Hey, dude, congrats on getting your CYSA. I got my CSYA. That was probably about a year and a half, 2 years ago. Solid cert, for real. I remember having to understand a lot of logs, like reading through logs and coding. So really, really good place to start, dude. Congrats on getting that. I know it's not easy, especially the performance-based questions. I remember those were a little bit tricky. Where does the server parameter point to? It points to this. And then we used it, and we got that. Going the extra mile, there's a way to use SSRF to gain access to the site's admin area. Can you find it? You won't need this. Okay, so here's a bonus point. We are going to figure it out. So we know that there is an admin area right here, but it's only available from localhost, and we have SSRF here that can essentially download files. So if we just do like 8087, The requested URL is not found. If you enter the URL manually, please check your spelling and try again. Let's just do anything. No file selected. Okay, so I'm curious what this looks like. If we're passing an HTML, so if you think, or it'd be PHP. If I do two ands. Okay, what if I add like a hashtag? What if I URL encode this? So one thing I haven't messed around with too much on here. Can we add that? So this, I need to update Cato. In the newest version of Cato, on this convert, it's actually like code blocks. Like you can make your own process, whether it's URL encoding or something else. You can actually tie this all together, almost like having cyberchef.io in here, but you can customize it. I don't know. You can see that, hey, I need to update Cato on this particular VM. Can I convert this right away? No. Okay. So if I go to convert, I just don't know the thing. Oh, no, not URL. What is the... What up, Hacks Guy? I'm pretty sure we need to do maybe this hashtag. It's kind of like a comment, because this, I'm like certain this is probably the way to do it, because we have our SSRF request to admin, and if we just URL encode it, I just don't know what it is. In Burp Suite, you can just control U. Maybe it's HTML encode. There, that's what I'm looking for. What if I do this? So once again, newest version of Cato, this is all built into it. I'm on a quite outdated version of Cato on here. I need to update it so we have all the cool new features. Send. We got something. Let's see if it renders for us. Okay. Maybe it's just rendering weird because it's a PDF. But we definitely got something. Let's go back to Intercept here. And it was his download resume thing. So turn on forwarding. Let's download his resume. And let me just paste this in. So what we're doing is we're specifying, hey, we want to go to the admin portal. And then we're doing a hashtag there. Essentially, hey, we want you to comment out everything else. Like, just send us to the admin portal. That works in my head. Yeah, look at that. This is what the admin portal looks like. But because it's downloading a file, it's downloading it as a PDF. But this is like the admin portal, and you can see we have our flag. That's actually pretty cool. I like that. So we don't actually input the flag. All right. Well, what's next? Why not enroll in our beginner level pathway or find another room to complete? Yeah, well, it is, I've been on stream for an hour and a half. Usually I go till 11, which would be about 30 more minutes, but I don't really feel like starting a brand new room in the next 30 minutes. Maybe I'll jump on stream like tomorrow night. But worst case scenario, guys, I will be back next week. Let's officially finish this room. Congratulations. For those of you waiting on YouTube, you've been waiting 6 months for part 2 of my OWASP top 10 room. There is part 2 of the OWASP top 10 room. But hey guys, I'm not going to just dive into a room with the 30 minutes that we have left before I usually sign off. So I'm going to call it a night here. I will just say, if you enjoyed my content, yo, first of all, subscribe to me on YouTube. Let me grab that link again. I will drop it over in the chat. Twitch is really just where I live stream, you actually can't catch any of my old videos here because I always have music on my 5-minute countdown and Twitch doesn't like me. But all of my streams, I have like over 160 videos just like this of working through labs like this, or just taking like a random hack the box machine and working through it live. I have all those streams on my YouTube channel. I have other smaller videos on my YouTube channel about career stuff or pen testing or web hacking or network pen testing, AWS pen testing. You can find all of that stuff on my YouTube channel. So hey, if you found this stream helpful, find me on YouTube, subscribe to me on YouTube. That is my main platform. Otherwise on Twitch, you can find me on Twitch every Wednesday night between around 9 p.m. Central Time, and I usually go till about 11 p.m. Central Time. So this time of the night that you're watching me, Wednesday nights, you can catch me here live on Twitch, and we can work through things, learn things, and hack things together. So guys, thank you for being here. Honor to have you take the time to hang out with me, and I will catch you guys in the next one. See ya.